Okay, so today we're going to be starting our studies on limits. And today we're just going to be going over what exactly is a limit, uh, why do we want to find limits, what do they mean, and that's it. That's all we're going to talk about today. So limits are very closely related to calculus. So this is kind of our introduction to calculus. And we're going to be talking about two uh two kind of main goals of calculus. So what are our two main goals? Well, our one goal is going to be to find the tangent, okay, tangent to a curve. Okay, and what exactly does this mean? Well, this means if I have some sort of a graph, let's just say, doesn't matter what it looks like, let's just say it looks like this. I don't know what this function is, but this is what it looks like. Um, and let's say I give you a point, let's say this point right here, and I ask you to find me the tangent line to this point. Okay, and all a tangent line is a line that only touches this point. Okay, so it only touches one point of a graph. And really what that tangent line is telling me is it's telling me the slope of this curve at that specific point. So at this point, that tangent line would maybe look something like this. Okay, so that's my tangent line. Okay, and that is giving me the slope of the curve at this specific point. If I give you another point, maybe let's say this point right here, and I ask you to find me the tangent, well, the tangent to this point is going to be something like this. Okay, so it's a different tangent. We can see it's a straight line. It's representing the slope at this specific point of this curve of this function. Okay, and we can see that if we take different points, we will get different tangents. We will get different answers. Let me draw that a bit better. We will get different answers. Okay, and that makes sense because our curve is changing, meaning that the slope of the curve at each point is changing. So that's one of our goals of calculus. And the other kind of goal of calculus is to find area under a curve. Okay, so area under a curve. So again, if I have some sort of a function, let's say it looks like this, and it goes on forever, it goes on this way, and I plot this on my piece of graph paper, and it looks something like this. Okay, and I ask you, I want to find the area from this point, let's call this point A, and this point B. Okay, I want to know this area underneath this curve. Okay, so that's the other point of calculus. So one point is finding tangent lines to curves, and the other point is finding areas underneath curves. Okay, and we're really going to start off with this finding tangents to a curve. Okay, so that's going to be what we're going to focus with when it comes to limits. So let's kind of discuss limits in a little bit more details. So let's say, again, let's say that I have some sort of a graph, and again, this is just a random graph that I'm drawing. It doesn't have to be specific. Okay, so here's my x and y axis, and I have some random graph, and it looks like this. Okay, that's what it looks like. And I give you this point, and I call this point P. And I say, I want to get the tangent to this point. Okay, that tangent looks something like that. Sorry, looks something like this. And I want to know, the equation for this tangent line. So what can I say? Well, I can say that I know that if we need an equation for a tangent line is just a straight line. So it's a linear equation. So I know that that equation is going to need 2 points, right? So I need 2 points to connect to make this line. I can't make a straight line with just 1 point, right? I need 2 points to connect, and once I connect those 2 points, I'll have a line. And, going kind of along with that, we also need to know the slope. And if we have 2 points, we have slope. So we also need slope. Because remember, if we're thinking about straight lines, that's what a tangent is. It's a straight line at a specific point of a curve. We're thinking of y equals mx plus b. And again, if we have 2 points, some x point and some y point, and we know the slope, if we have 2 points, we can calculate the slope. We can calculate the slope, we can substitute one of the points in for x or y, and we can calculate our y-intercept, and now we have the equation of a tangent. Great. So that's the first problem. We need 2 points. We also need the slope, but like I said, but if we have 2 points, we can calculate slope pretty easily. So really the crux of the problem is that we need 2 points. So how am I going to get these 2 points? What am I going to do in order to get this? Well, let's consider something like this. Let's consider a similar situation. Okay, where we have our x and y axis. Again, I'm just going to draw a graph here. It's not going to be the same, but it doesn't matter. Okay, this is my graph. And again, I'll give you a point P. But in this case, I will also give you a point Q. And I'm going to make that point Q right over here. So this is point Q. And now, instead of making a tangent line, which is a line that only touches the curve one time, I'm going to give you a secant line. And what a secant line is, you might know what it is. It is something that intersects twice. Not once, but twice. So it's going to intersect this graph twice, at least locally. So this line is going to look something like this. Let me try and get it straight. There we go. So this line now, this is a secant line, okay? So I can secant line. Okay, so now I have a secant line that is labeled as PQ. Okay, that's my secant line. It's joined by the points P and Q. But I don't want a secant line. I want, what do I want? I want a tangent line. A tangent line at point, in this case, let's say point P. We can choose point P or point Q or any other point, but I want it specifically at point P. So how am I going to turn the secant line PQ into a tangent line at point P? Well, we already know that, again, logically, you cannot make a line with just one point. But here I'm saying I want a line at one point, that point being P. So how are we going to bypass this problem? Well, one way that we can think about it is, what if we bring Q closer to P? What if we try that? So what if I bring Q maybe halfway as close? What if I put Q here? And I call this Q, let's say, prime. Okay, that's what that little kind of apostrophe is. That's called a prime. Okay, now I have Q prime, and now my secant line becomes this. Okay, and it's obviously changed in the direction that it's going, but now it looks like it's a little bit closer to Q. And again, what if I bring it over to here? Well, now my secant line is going to be something like this. Okay, it's going to be something like this. And again, we can see it's changed pretty drastically as well, and we can call this Q double prime if we want, doesn't matter. And now the question is, what if I keep bringing Q so close to P? Okay, I can always go a little bit closer, but that's the idea of this. So we have our line PQ, and our line PQ isn't a very good approximation. Isn't a good approximation of the tangent line at P. But what happens if I bring Q closer to P? Okay, and what if I keep going? What if instead of bringing Q closer to P, I bring Q infinitesimally, infinitesimally, I don't know how you spell it. That's the correct spelling. Infinitesimally close to P. This is the important question. Okay? As I get closer and closer and closer and closer and closer to P, I will get more and more and more and more accurate as to what the secant line is approximating the tangent line is going to be like. And the whole idea of limits is that we can actually get so close, the points P and Q will be so close that they will actually be the same point. And when that happens, we will actually know the equation of the tangent. And that is what limits are. Okay, bringing this infinitesimally close, this is what limits are about. Okay, we want to bring the points P and the point Q so close together that they are the same point, and then we will be able to know what our tangent line is. Okay, now it's important to know that P and Q can never actually equal one another, because again, then we would just have one point. But the idea is that they are so infinitesimally close together that they are basically the same point. And in fact, they are so close to being the same point that we can say mathematically that they aren't the same point, but the approximation that that line from P to Q gives us is actually the exact same line as the tangent at the point P. And so that's what limits is all about. So limits, let's kind of just talk about it. Limit is asking what does a function, let's call that function maybe f of x. Okay, so what does a function, some function f of x, do as its variable, in this case x, because this is a function of x, as its variable x approaches a given value. Let's call that given value a question mark. That is what we're asking with limits. So in this case, we have some function. It's this curve that I have here, f of x. And what does this function do as the variable x approaches a given value a? So in this case, our given value a is p here on this graph that I drew here, and x is our variable q. And q is getting closer and closer and closer and closer and closer to p. You can also think about this as being x, and this q, or sorry, that this p is actually a, and this q is x. And what happens is as this x gets closer to a, and the way that we are going to be writing limits is going to be like this. This is what it's going to look like. We're literally going to write lim, L-I-M. This is just short form kind of for limit. Okay, then we're going to write our function f of x, and underneath lim we are going to write this little x arrow a. Okay, and what this means is if I'm reading this out, I am saying what is the limit as x approaches a for the function f of x. Okay, so what is the limit as x approaches a of the function f of x? And that is going to equal, it's going to equal some number L. We'll call that number L. Okay, this is just a number. It can be a positive number, a negative number, a fraction, a decimal. It can be pi. It can be any number. Okay, so if I'm reading this, I'm saying what is the limit as x approaches a of the function f of x? And if I'm answering it, I'm saying the limit as x approaches a of f of x is equal to some number L. Okay, and that's all that limits are for right now. Okay, and in the next video, we're going to get into a little bit more detail with limits, and we're actually going to look at some problems that we might experience with limits and how we can bypass those problems. So that's coming up in the next video.